Hello and welcome back to a new video here on the Lötwig Fusel channel. In today's video we're going to continue on in commercial grade C++. Now last video we implemented the first service. If you want to recall, well, it was this web page that I still have open, but I can refresh. There we go. We have an actual like hello world example running in the web browser. A C++ hello world in the web browser, something that's really cool. We are using CPP, HTTP It's still like personally for me one of my favorite C++ libraries because it just opens another dimension to your C++ applications if you're not making games. So yeah, that's it. But yeah, that's not the topic of today's video. In today's video we want to remove these headaches. We want to write a service manager basically that manages the services for us. So we have the system where we had the service basic service and the basic service CPP, and we already have a service manager. That's cool. Okay, so let's start by including a few things, CG, CPP, and I'm going to go to basic service. That's what we're going to include because that's what we need. Let's terminate the application here. All right, so let's get started by implementing services. First of all, we need to store them somewhere. For me, I think we can just use a vector. Not really need to use a vector there, but yeah, we can. Let's just do a vector. And then let's also include memory because services need to exist somehow and they will exist in the pointers. And what we're going to create for services is we are going to create unique pointers for the services. Services are not meant to see each other. There's no need to have a dependency chain between them. So we're going to have unique pointers. Okay, so std vector of std unique pointer for the basic service. So we're going to have a lot of pointers for basic services. Now what we need to have a way to like create a service inside of that, and I'm going to do this with a simple void create service. Create service shall create and put an element onto that list. And in order to do that, we're going to have a template. So template type name t. Okay, so that's basically how we did it. That's going to be a type name t, and I want to be able to also put in arguments. So we're also going to have arguments in here. So then what I want to have here is I want to have a type name here, std enable ft. So make this a bit like add a switch here so that it's not always available. We need type traits for this, and what we're going to do is base of v. So what we're going to have is we're going to have a base class, which is the basic service, and the derivative is t. So t needs to be a basic service in order for that template to function. Let's maybe format it a bit better so that we can see this. And maybe I want to add another logic to that. Is there something is constructible is actually what I want to have. Is I want to see if t is constructible with the arguments that we have. So only then this works. So it needs to be a basic service. Let's maybe make this like this. And it needs to be constructible in order to work. I think with like concepts and how is it called? Contracts, concepts, I don't know. I think there are these days a few more better options to do that, but I'm personally more the guy that works with these. I'm not really came behind concepts. Did played a bit with them, but really was not too much of a fan of that. Okay, so now we can create the service based on the arguments. That's quite easy how we do that. Basically what we're going to say is we're going to say services pushback. And what are we going to push back? Well, we're going to push back an std make unique of my class t with the arguments expanded, and we can actually say forward args so that everything is forwarded. I think we can even inline that. That's not a so big call. And there we go. Now we have created a service within the service manager. Let's add some documentation here. Param args, t param t args, this is the empty one. Okay, so type of the service must be based on basic service type of arguments to construct the service. Arguments to construct the service. And then we have a quick comment, creates a new service in the container. And actually what I want to do is I want to have a conditional bool m is running, which is going to be false. So what I want to do is I want to interlock that. So if not running, I'm going to do that, or actually let's do it otherwise. We do the m is running, and then what we're going to do is we're going to go for an exception here. No, I think we have our own exception class. Do we have our own exception class? I don't think so yet. No, we don't have an own exception class. That's something that we would need to do at some point. I just want to throw quickly an std runtime error here. Did accept is what I want to more look like that, or let's actually this is a more like a logic error because it's a wrong like calling convention. Can't create services while running. That's something that we still need to do. We need to make it all exception safe. Maybe we do that after the service manager videos, or maybe next video already. That depends on how far we get today, so that all of this works. All right, so now what I want to do is I want to have a void start and I want to have a void stop. Okay, so these are the two functions that are now going to be implemented. Starts the service manager, and then here we have basically stops the service manager. All services, more or less. So service manager, just a container for all the services. So how does that work? We're going to go in here, and then at start, what I will do is I will say for auto reference service in my services, services, I'm going to do something, and actually only if not is running, say something, and then we do m is running is true, and then I go through here and I say service start in order to start the service. Then we do the same for stop, but stop is a bit more complicated actually. If m is running false, in here auto service services, but then I will basically say stop, so I will send the signal to all services to stop, and then I'm going to iterate again through the services, and I will call a wait, so that I wait that all of the services are finished. And that's more or less what the service manager is doing. That's it. That's everything. Now what we can do now is we can now utilize this service manager here. So how do we do that? We are going to go for the service manager. Okay. Then basically what I'm doing here is let's get this one. CGCPP service manager, or services like that. And then services here, and then what I do is I'm going to create service. Okay, so this clashes with the Win API, that name. That's a bit odd. Sometimes I don't really like that. I want to call this then like new service. That's okay for me to rename it, but I'm a Windows guy, so I am always on Windows, and then basically, yeah, I just rename my classes. All right, so how do we do it? Services, new service, www service, and then we can go like services.start to start the service managers. Let's maybe wait like 20 seconds this time, so it goes a bit faster. And then we do services.stop. Okay, so start and stop. That's all good. I can run it, and I should be able to run the service. Service thread started. If I refresh, there you go. It's running. The thread is running, and it should stop any second. Because I said like 20 seconds. 20 seconds can be quite long. We are only at 15. I should have gone even lower. But yeah, we should be here now. Okay, so the thread stopped. That's good. You can actually see that we have quite a lot of threads that are stopping. It's not only like this service thread with 23996. It is probably in there. 23. The question is it the first one, 23996, or is it the last one? Here, it's the last one, 23996. There's somewhere is my main thread, and the other threads that you can see down here in the console, they are from HTTP-lib, because they basically implement their own, like threading model, so that they start threads for working the HTTP requests, which is something you need to consider, because basically it's a multi-threaded HTTP server. Alrighty, just out of the box, easy. Quite cool. Why the hell is that class so big? Is it because of the server? Yeah, it's because of the server. The server is just quite big, but that's okay. All right, so now we have the WW service in here, and we have a service manager. Now what I want to do is I want to replace that line. I hate this one. I need to replace it. And what I will do is I will go to util, and I'm going to create a new item in here, and I'm going to call this one application, or how do we call this, signal interrupt.h. Signal interrupt.h, and signal interrupt.h is going to listen to a signal. And let's make it like that. Class signal interrupt, public and private. And I think what I want to do is, yes, I know it's maybe not the best thing these days. Maybe not the way it listens for interrupts. This is not the best thing to do, but I want to make this one completely static, this class, and I want to make it a singleton. And I want to just basically delete, or not delete, but default the private constructor. So basically, yeah, you can delete this one. I just want to make this one a singleton, basically. And well, actually, I think we can get away with disallowing construction at all. We don't need an instance from that, because we just have a static bool as signal received, which starts to be false. Inline, we need to inline it so that it works. Inline static bool as signal received false. And then the public interface is quite a common one. We can have a bit more final answer. We have a void register, or a static void register. The only thing that I'm making this a class is so that I have structural storage for the signal received. You could just make these, could do this another way as well, but I like it like that. So there's signals for interrupt events. So basically what I want to do is I want to wait until somebody presses Ctrl+C on the console to close the application. For that we need to register signals, and I will steal code for that again. I was already stealing code here, but I also have this for the interrupts. So if I go to lib and util, there should be the keyboard interrupt.cpp, and I have the signals in here. And I also did have a note that I registered. But basically what I want to do is I want to do it like that. And then we need to have csignal. So hashtag include csignal in here, so that we are up to the signal handler. This is, I think, a special Win32 signal handler, so I need to check if it exists before I'm registering it. The other ones are like quite common signals. So we have the abort, the terminate, and the interrupt signal. And on Windows we have the sig break, so that we can register all these. For that we need a signal handler. And I think what I have done here is I have implemented it like this. It's a void with an int. So static void signal handler, like that, in signal. So that's the signal that was received. So let's maybe add a comment in here. Is called when the system receives a registered signal. And this is the signal that is going to be sent, like the ID of the signal that triggered the function call. Simple like that. Signal like that. And what I want to do here is I don't want to do any like checks which signal occurred, because we just registered all these handler and they all behave the same. So the S signal received is to true. Then I do a static bool check signal. And then maybe we're gonna have a bool clear that's set to true, so that's a check signal, and then optionally also clearing the signal, so checks if the signal was received. By default clears it to the not received state. So maybe sometimes you want to ignore a signal, and then this is good to clear the flag so that you can receive any further signals. So clears true. When true, clears the internal buffer. Return true when signal received. Otherwise false. So now let's implement the check signal function itself. So what I do is I'm first going to check if the static signal was received. If this was the case, we can definitely return true, otherwise we return false. In here, if we have the clear flag, what I do is I go my signal received and I set this one to false so that there was no more signal received. Okay, so this is basically what happens. I do want to add a bit of instrumentalization into that code, so let's quickly go and include spdlog. Hashtag include spdlog in here, spdlog, so that we can get a bit of an information. And what I want to do in here, spdlog info, terminate signal received, ID. We have the signal ID that I just want to pass in here. We could get these names here as well, but I don't want to get the signal name. For me, the ID of the signal is enough to see which signal was receiving that call. Okay, so now the only thing left to do is to actually use it. So let's include util signal interrupt in here. And then let's go for CGCPP signal interrupt register in order to register this interrupt system. And then I do here while not services or not services CGCPP signal interrupt check signal. So while not signal was received, we can just leave for like 100, let's say milliseconds, something like this. So we have start, some dummy wait block, and then we have stop. That's basically the idea. And what we can do in this loop, currently we are sleeping, but in this loop we can add a lot of more logic that might be required. That is like maybe updating systems or pulling messages around and things like that. Or having a queue that can only be run in single threaded use cases. We could all do it here. So I can see the homepage works. I can refresh it. I can make the memory rise in order by just holding Control F5. Now it seems like we floored out on the memory allocation. It can happen for CPP HTTP lib. And yeah, we are here with 4 MB with a web server. Now in order to close the application, I'm going to press Control C, which you can see we are basically breaking. And sometimes if you're getting this one, in the Ask Copilot, show call stack, start live share session, copy details, you think this is a problem. But actually this is a common exception that's just always thrown, exception thrown at in blah blah blah, Control C. You just need to uncheck this one. Break when this exception type is thrown. Except when thrown from, I don't know. You just unclick this one, click play and continue on. Everything works. You just need to acknowledge one time to Visual Studio that you are really like, you know what you're doing. Control C is not an abnormal thing. And yeah, if you take a look at this, terminate signal received, ID equals 2, and then it goes on with service thread stop. So you can see our application works. We can start, we can click on the console, we can stop it whenever we want. And that's the like whole idea. And by the way, signal 2, it is, which one is it? It's the SIGINT. Control C is the SIGINT. Abnormal termination triggered by abort call. Software termination signal from kill. So there are multiple ways of like terminating the application in a not so nice way. Yeah, that's basically the idea. Maybe we're going to implement a bit manual call to std abort, for example, if something fails. So, for example, if we go to main again, I think here would be good to call std abort. I think std abort is then basically just triggering the signal, and then we handle it accordingly, I think. But I would need to instrument that a bit. Can I instrument this? I can quickly just put it up here in order to see what happens. This should regularly terminate, I think, the application. And we can just say ignore. No, it's not going normally. It's not abort. It's not a normal termination, sadly. Could be. What was the other one? It's the signal terminate. Software termination signal from kill. But it seems like I cannot do it. It's okay. So let's not do it like that. I want to have normal termination. We could later on add a feature that you manually trigger this abort. Let's maybe implement that, right? We can have a single interrupt. Let's put in a static void abort function in here. Or let's call this one software. Let's call it software stop. Triggers Control C. Stop by software. That's what I want. Let's create a definition in here. Let's basically just set the signal received to true. And then let's go spd log info software stop triggered. Software stop triggered like that. And then in the main, what we can do if something is wrong, we can basically say, CG, CPP, signal interrupt, software stop in here to trigger a software stop. I think this is a reasonable thing to have, that we can trigger a software stop that is like casually, nicely aborting the application if there's something wrong. Software stop triggered. There you go. That's the idea. But of course not here. It was just for testing out. Okay, so I think that's a quite nice section that we have done for today's video. We made the service manager run a bit more smooth. By the way, I think we could also trigger it like this, right? Let's try it out. I think this one should fail. Bind should fail if we create new 2 services. No. It actually, we can run 2 on 1 port. That's quite entertaining that this works. That's really entertaining. That the bind already, it could be that the bind already failed. And that this one was doing nothing. Nobody knows. Nobody knows what they're doing internally. Where the second server was listening now. But yeah. Actually I wanted to stop the video. Thank you for watching. See you in the next one where we're going to go for the exception. And yeah, make sure to like and subscribe. Have a nice day. Bye.